Now we have Badri Rajasekar. Yeah,
That's right.
it's almost. Excuse me for that. CTO of TokBox, and he will give us some kind of real experience on how you can use WebRTC. And I'm keen to hear what you are saying.
Oh, thank you. Excellent. Good afternoon. My name is Badri Rajasekar, CTO of TokBox, and for those of you who don't know what TokBox is we are an API platform which enables application developers to sort of integrate real-time communication experiences into your application, whether it's mobile or on web. And I'm very happy to be here in this sort of cloudy Redmond day. In a previous life, I used to work in building 26, 27 in the core operating systems division here at Microsoft. So I'm a little bit nostalgic to be back. But anyway, that's not why I'm here. What I'd like to talk about today is mostly talk about some of the problems of using WebRTC in the real world and sort of what the big gaps between what the standards address today are versus what the market actually wants. And as I was thinking about this presentation, I was a little bit schizophrenic in the sense that, should I talk about all of the technical details in terms of where the gaps are with respect to what the standard addresses, but that's not really going to be that useful unless there's a higher level conversation around what the big use cases in the market are. So what I'd like to talk about today is, at a very high level, the promise of WebRTC, or sort of what it aims to bring to the market, is really sort of break up the old world paradigm of siloed applications, where applications whose sole purpose is real-time communication, whether it's a Skype or WhatsApp or what have you, and bring sort of real-time communication in context. So if I was running a website or an application, the communication really has to be centered in context. And that's really the big promise of WebRTC. And so what I'd like to do is walk all of you through some real-world use cases. And TokBox being a horizontal API platform, we have a lot of visibility in terms of sort of what are the broad strokes in terms of what are the use cases, how are people using real-time communication in the web. And then I'd like to delve a little bit into some of the big problems we face in sort of making that happen. The first thing I would like to say is WebRTC is absolutely gaining momentum. And this is sort of the crossing the chasm model. If you look at 2013, 2014, there was a lot of technology evaluation. Is WebRTC really going to pan out? Is this a technology businesses need to bet on? And stuff like that. And what we're really seeing is it's making a huge amount of inroads into a whole bunch of various segments and markets. And I could talk about this for hours, but what I'd like to do is maybe talk about 3 example use cases across 3 very distinct verticals: customer service, distributed workforce, and sort of education, just to give an example of what's going on there. Here's a very simple sort of example which exists in the wild right now. Let's say you were painting some wall in your house, and you really needed some help in terms of, okay, what's the right color I should be painting this wall with? There's this company called Valspar, which has this product called Color Connect. And what you can do is you can basically point your front camera to the wall you're sort of trying to paint, and you can actually initiate a direct call from the app to a Valspar color consultant. And what the color consultant can do live as he or she is talking to you is walk you through that process and essentially even overlay different colors on the video window so that you can sort of juxtapose that and see if that works out or not. Actually, obviously, the fundamental feature in this app is the real-time communication bit, but it's sort of an interesting example of what a use case potentially looks like. And that's just one example of sort of the customer service use case. I think there's a whole paradigm shift which is happening in customer service. So 5 years ago or 6 years ago, I would have to call a restaurant to make a reservation. Today, hardly anybody does that. People use OpenTable or whatever. So this entire modality of communication where I was required to pick up a telephone and call somebody is sort of moving to the web. And the next logical extension of that is sort of enabling very rich real-time communication in those experiences. There's one of the stats I heard recently, which I thought was pretty interesting, was 75% of the Kindle Fire customer service calls are actually addressed by the Amazon Mayday button, which is sort of a one-way video call to a customer service representative. So a lot of activity in sort of that vertical. Another example is this company called Fluke. For those of you who don't know, what Fluke does is they're like a big leading provider for sort of electronic test tools, multimeters, biomedical equipment, and stuff like that. And they built this interesting application called Fluke Connect to streamline their workforce. Let's say I had a faulty fuse or something, and there's a contractor, an electrician who actually comes in and who's trying to sort of debug that problem. And let's say he's a junior technician. What he can basically do is point the camera to the faulty fuse or what have you, call an expert back at Fluke headquarters in some sort of centralized location, and the expert can actually look at that and walk him through, should you snip the red wire or the blue wire or what have you, right? Again, very interesting example of real-time communication basically being used to streamline the distributed sort of workforce, reduce the amount of time on site, and things like that. And finally, obviously, another interesting example is education. Education is a vertical where you see a lot of activity. This is a company called Minerva. What they are aiming to do is to actually disrupt Ivy League education, sort of even real-time online education, and build these very rich, integrated classroom experiences where you can interact with like professors, you can actually take like live courses, and sort of even interact with your fellow students, and make it as rich and seamless as possible as an online experience. So those are three sort of example use cases of things we sort of see in the market in terms of, this is what the market really wants. This is what people are building. And the question of what it takes to actually use WebRTC in the real world is, it turns out that it is quite hard. A lot of people have spoken about this in terms of, mobile being sort of a big component of any sort of real-time communication application in the future. I think there's no disputing mobile as being an important component. But the problem is there is still a whole bunch of issues which have not been solved well, either in terms of being addressed by the standard or sort of being addressed by the default implementations which exist today. I'm not going to go into the big elephant in the room, which is the codec conversation. That horse has been beaten to death. So really, regardless of what an MTI codec for WebRTC looks like, whether it's H.264 or VP8 or what have you, really the big issue is there needs to be a lot of work which happens around performance optimization. It's not at all usable in sort of a mobile scenario in several use cases, let alone the poor connectivity. It's just computational efficiency. And there's a lot of talk around sort of video codecs and all of that. But here's a very simple example of an internal test one of our automated tools did. This was basically a WebRTC build 6509 running on an iPhone 5. The 200% you see is basically 100% for each core. So it's 200% would be both the cores. And if you actually look at the Opus encoder, sometimes is computationally more encumbering than even the VP8 encoder. Now, if you actually think about this, I mean, there's no way it should be, audio encoding should be like this inefficient. And imagine a world in a mobile device where somebody is trying to do a multi-party conference, or maybe even a three-way, and let's say you didn't mix your audio signals, you would now be decoding 3 audio streams with massive computational cost, really not that usable. So when it comes to mobile devices, I think there's a lot of conversations around efficiency, but really performance and performance optimization needs to happen relatively fast for real-world use cases to sort of take off.
I'm going to comment.
Yeah.
Real systems don't actually encode Opus in the mixer. They forward it.
Right.
So that issue doesn't really exist.
But on the end user device, if I wanted to encode.
Yeah, that's right, on the end user.
On the end user device. So this is not so much in the let's say if I'm using a mobile device, I'm mostly looking at the end user.
Can you please repeat the question? It wasn't audible.
Sorry. The question was, a lot of cases, there is no mixing or there is no encoding the mixer, and basically it forwards Opus. So this is not a computational efficiency problem there. Really, the problem is on the end user device where I'm actually encoding. The end user happens to be a mobile device. The second sort of issue with mobile is use case enablement. There's a lot of interesting use cases where, in a customer service scenario, for instance, you might want to capture the screen and do some sort of a screen capture on the other end. And presumably, the engines basically don't do a lot of distinguishing between, what could be a video stream versus what could be a screen capture. There are ways and flags you can set, which basically make sure that resolution is not degraded if a stream is tagged as a screen capture. But really, there is not a lot of easy sort of access from these default implementations to surface that out to an application level to make that happen. And thirdly, here's another sort of example. Just as an example, it just seems like a lot of effort is happening around the standards committee and sort of implementations in terms of optimizing the experience on the desktop. Not a lot of effort is being put towards mobile devices, even in terms of sort of implementation. Here's sort of just an illustrative example. This is one of the scatter plots from an internal sort of test we were doing, which basically plots estimated bandwidth reported from REMB packets against audio packet loss. And the green dots are basically from an iOS endpoint. And the orange dots are basically from an Android endpoint. And as you can see, receiver estimation is completely broken in Android. Basically, the REMB packets were not estimating the right bandwidth at all. It's just constant. This is across two different versions. The practical impact of this is if you're using Chrome on Android, whatever, there is no real adaptation which happens, and your quality is really bad. And credit be given to Google, they jumped on it and tried and fixed it. But really, the point I'm trying to make here is, there's not a lot of effort which is being put in sort of making sure the mobile experience is also sort of keeping in lockstep from a quality point of view. Since I don't have a lot of time, I'm going to go beyond mobile. There are very simple things in the real world which sort of block adaptation or how these apps are built. Here's another example. This is again from one of our internal instrumentations. Get user media is the actual function to actually acquire the device. And you can see this is across Firefox and Chrome. Approximately 10% of people have get user media failures in some of the reference apps we looked at. And the reason was very simple. The door hanger, which shows you an allow deny, people would always click deny. And there was, or they would forget to click anything and they wouldn't click anything, right? There's a lot of behavioral sort of issues that still need to be solved. There are app developers who build giant arrows pointing to the top right of the screen, which say, click here. Next thing you know, Firefox changes it to the left, and therefore it's pointing at the wrong location. There's a lot of interesting things which need to happen to incentivize the right user behavior. Multi-party and media. Again, there's been a lot of conversation in this room around MCUs, what the right topology should be. Again, there is no native support for sort of multi-party, so somebody would have to end up building your own MCU or use a service or buy a commercial MCU. And even when you're doing conferencing, we absolutely need support for simulcast and temporal scalability and things like that to make sure we don't sort of degrade to the lowest common denominator. These are pretty big ticket items which presumably WebRTC or WebRTC 1.1 will hopefully address. Again, SDPs are being used as sort of surface APIs. We ourselves do a lot of the developer will have to do a lot of mangling of the SDPs to actually do pretty rudimentary things. One of our engineers figured out a flag which can be set on the SDP, which will enable sort of simulcast in Chrome, which is what Google potentially uses in Hangouts. But all of this requires us to mangle SDPs. And in a future world, this could lead to a compatibility, interoperability nightmare. And obviously, in the real world, a lot of open questions around scalability and deployment, right? What's the right topology? The standards have some recommendations in terms of topology. Maybe you use some sort of multi-unicast, but as the size of the conference increases, these are not really great solutions. So fragmented ecosystem out there. To some degree, fragmentation is good for service platform developers like us who actually provide some sort of abstraction layer. But really, fragmentation is hurting adoption. Safari and IE support, obviously open questions here. Even if the latest version of IE or some future version of IE were to support it, what about legacy versions of IE? There's a lot of incompatibility between the implementations of Chrome and Firefox in itself. For instance, you can't use multiple media streams over a single peer connection, as far as I know on Firefox. You can with Chrome. So there's a lot of optimizations which you could potentially derive, but fragmentation in the market is not enabling us to do that. And finally, at the end of the day, the reason I'm sort of passionate about all of this is WebRTC is an amazing standard, and I think it has enormous potential in sort of moving the ball forward in terms of real-time communication. But it is competing with close proprietary standards. And I think at the end of the day, end users want something which just works. And the faster we can unblock all of these hurdles, the better is going to sort of help adoption. And finally, I'm not going to delve a lot into this, but there's a massive amount of capital locked up in enterprise legacy hardware. And interoperability with legacy hardware is sort of a big ticket item. Whether this is NAT traversal, simple things such as how do I deploy my turn servers, where do I deploy it? Maybe the standard needs to look at things like in a browser, just like I can configure a HTTP proxy, maybe I should be able to configure a turn server. And we have some sort of policy around turn discovery within an enterprise. There are all these interesting things which we could do to sort of ease adoption within enterprises. PSTNs and SIP, I won't delve into. I mean, obviously, there's a whole bunch of gateway level issues with making sure things tie into an existing infrastructure. So that's really the end of it. And what I'd like to conclude by saying is, I saw the stat saying there's going to be 6+ billion WebRTC enabled endpoints by 2019. I really think it's up to all the thought leaders in this room to sort of help move the standard forward and reduce the hurdle to adoption. Thank you.
Are there any questions to Badri?
Two and a half years ago, Enterprise Connect, VoiceCon was exploding with WebRTC. It was the flavor of the conference.
Right.
Why 2.5 years later we're in this position that it's really it barely moved? I mean, it's supposed to change the world. It doesn't seem like it is.
I think there was a lot of talk in Enterprise Connect and during that time in terms of WebRTC being an interesting technology, but as you guys know, enterprises do take a long time to move. So a lot of them are actually entering pilot phases and proof of concept sort of evaluatory mode at that point in time. What we are actually seeing is people are moving towards ship mode in terms of real WebRTC deployments. People are actually shipping real-world WebRTC deployments.
But with a major browser like IE not supporting it, how does that?
Just a comment. People don't understand. We all use WebRTC every day. Every time you use Amazon Mayday, you're using WebRTC. Every time you use Vonage, every time you use Facebook. Basically, WebRTC is now ubiquitous, except it isn't in the web. the actual stack that's described here is being used everywhere. More than 1 billion people are using it every day. So when people say WebRTC doesn't impact me, you don't even know you're using it. It's like to say, do you know the exact bits that are in the stack that you're using of every device, right? Do I know, oh, FEC doesn't exist? Well, it's in your, it's in your stack. So WebRTC is ubiquitous. It is just not being used, deployed widely on the web, but it's being deployed in mobile apps. So people don't know this. WebRTC is already ubiquitous. It's just not advertised, but it's in there.
Yes.
Yeah, if I may add to that, actually, I think that there was a misconception that WebRTC, even though it's an endpoint design architecture, it would also solve problems on the back end. I think Badri made a very good point that a lot of the things that have to do with multi-point communication, etc., are not solved, and they couldn't, because this is not a solution for the back end. But in the excitement, if you wish, of the early days, people thought that, as usual, oh, this will be the magic bullet that will end, all our problems. But the fact of the matter is, just because you put an API around something, you haven't solved it. You may have given it a way to access it programmatically from JavaScript, but the underlying, fundamental engineering problems that exist for bandwidth estimation, error resilience, how you do the multi-point, all these are exactly the same. Okay, so I think what WebRTC set out to do is being accomplished, as Bernard said. Okay, but it'll take a while, if you want to see it on your web browser and be called as such. Okay, so I think we'll be more later today on this subject, but I think it's important not to have this misconception. Okay.
Right, and even these numbers of 6 billion WebRTC enabled endpoints, I read a stat somewhere where it said, it took like 17 years for smartphones to actually reach 1 billion endpoints. It took like 1.5 years for WebRTC to do that. I think there's massive reach in WebRTC. Really, the point I'm trying to make here is that can be accelerated if some sort of low-hanging fruit barriers are basically solved by the standards committee.
Thanks for the presentation. Actually, very, very useful to learn. And I agree with Bernard that we're using it every day. You made a business out of it, so
right.
it's not like it's the dream pipe. Right. The things that you mentioned as issues is the fact that it's not standardized yet. Those interoperability things will have to be resolved when the standard moves from the last call into candidate recommendation. So I do think that they will be addressed. The turn thing you mentioned, actually, as I remember, that right. is settable in the API.
Oh, yeah.
You can set the turn server to your choice.
Correct.
As a developer.
The ICE framework and actually all of the NAT traversal built into it, actually you can use turn to relay media, but that was the point I was trying to make is going beyond using an existing turn server. There are interesting things you could do within an enterprise to manage turn deployments, and that can be addressed at a much higher level.
Just one point, just said this is the reason why we are here in IMTC. I think we are solving those kind of issues.
Exactly.
And I think everyone is invited to join the groups and to participate in those groups to get more insight and light into that.
Someone who hasn't actually been following the codec discussions, could you briefly summarize where we are today?
We are opening a hornet's nest. So basically, I will not go too detailed into it. This high-level summary is the video. So there are mandatory to implement codecs, audio codecs for WebRTC, but there is no mandatory to implement. There is no MTI video codec for WebRTC as yet. The default codec, which is sort of used at this point, is VP8 in Chrome, and was VP8 in Firefox, and Firefox now supports also OpenH264 or H264. So really, I think there's a lot of conversation around what the right MTI codec should be, codecs should be. Maybe there should be no MTI. This is a hornet's nest, and I won't go too deeply into it.
But nobody supports H.265 today.
Yeah, I mean, sorry?
In what context? Sorry.
Any browsers?
As an
browsers.
Yeah, as an MTI option.
No.
Yeah, nobody supports H.265 as I know. Go ahead. Yeah.
Because they need to record it. They want to be recording the question. So.
Got it.
The context is very important. Yeah, the iPhone 6 supports H.265, so it's supported. Sorry? Yeah, that's why the context is important. So you meant supported in the context of WebRTC, etc. in the browser. Okay, yeah, just so that people don't have the wrong impression. Okay, it's already out. Yeah.
Right. And it's not only what the right MTI codec should be and all of that. There's even practical sort of implications in terms of even if there was, access to hardware acceleration, if there was a H.264 hardware encoder, does the OS provide programmatic API access? Until iOS 8, this is not even possible to get access to the H.264 encoder in iOS, for instance.
Okay. Thank you very much,
Thank you very
Badri.
much.
It was a cool discussion.